Hello everybody, my name is Linda and I'm currently a PhD student at the Luxembourg Center for Systems Biomedicine, which is a research facility in Luxembourg. So, where is Luxembourg? It's in the heart of Europe, so if you want to know more about that, just go ahead and Google it because it's a very nice place to live and study and do research. So I'm in my last year of PhD studies, which is like 3 years in Luxembourg. And today I'm going to explain a bit about my project, what I'm actually doing, and what my goals are, and maybe I'll get you interested in it. So, just like other research projects with fancy names all over the place, mine also has quite a catchy one, so it's called Cosmic. It's however not really about the universe, but it's about another kind of cosmic environment in us, which defines who we are and which influences us in a positive or negative way on a daily basis. So it's not about countless stars, but about microorganisms that are living in and on us. So actually all these bacteria that live in and on us are making quite a number. So the numbers are under dispute for the moment, but it ranges from as being equally sized with human cells, so as many bacterial cells than human cells, up to like 100 times more. So we're not going to count all these bacteria in us and on us because this would take a lifetime to count and would be quite impossible. But we are all pretty sure that all these bacteria are having an effect on us. Which is not very small. So actually, if you consider that nearly 2 to 3% of your own body weight is only bacteria and mostly residing in our gastrointestinal system, then you could quite imagine that all these bacteria do something with you and quite influence you on a daily basis. So that's what I'm actually researching in my project. But not only in the adult microbiome, so all this bacteria that are living in and on us, but I'm looking at it in newborn infants. So I want to see how the colonization, so the very initial contact with bacteria, is being done in newborns, and how the newborns are evolving and developing with the bacteria. Since some years it has been shown that actually the delivery mode is very, very important in how the baby is colonized initially. So, which is quite logical. So if you think about that, so if you have a naturally vaginally born baby, of course the baby will get the first bacteria from its mother. So during the passage through the vaginal cavities, I don't know, the baby gets colonized by bacteria that are just of original and natural origin. And if you have a C-section born infants, of course this very close contact with this vaginal bacteria is not happening, but the bacteria will be from the environment. So the baby will not have this transmission from mother to infant from the vaginal environment first, but rather from contact, from skin, from the health people working with the mothers, which is not necessarily bad because these bacteria are not necessarily harmful or pathogenic, but the initial profile is just not how it is supposed to be. So the initial profile might be completely different from those from vaginally born, and now a lot of studies suggest that actually the very initial colonization phase is very important for actually predispositions for different diseases later on. So the profile you acquire at birth will predispose your health and your immune system to be more susceptible for different diseases later on. Actually, that's what I want to see in my study. If there is the changes to different compositions in C-section and vaginal infants, and how these are influencing the baby on a 1 year time span. And actually I do see differences, so maybe if I get you interested in that, you can look at the subject a bit more if you're interested, who knows. And yeah, so I'm taking the infant's poop because that reflects the microbiome of the gut in the best way, so I cannot just chop off their intestines. I wouldn't do that, it's not very ethically correct. So I take the poop and then I extract DNA, so all the heritage, the material, the genetic material that I can get out of it from the bacteria, and then I'm sending it for sequencing. That's what what we call like identifying what is inside of the bacteria of the stool, what kind of bacteria are there. So afterwards I do all the analysis and then I compare between vaginal and C-section. So now it's get too scientifical and too numbers, so I'm just gonna skip that. So we do see differences, and there is a delay in colonization of C-sections and vaginal deliveries. So what is now being done is actually also pretty interesting, is that they try to recompose the initial microbiome by colonizing the babies that are born by C-section with the bacteria coming from the vaginal environment of the mother. So they want to reconstruct the natural vaginal profile of the microbiome and want to get the baby in the right track again. But still there's a lot more to research. It's not as easy as that. So there's a lot of different effects on the microbiome. There's nutrition. The milk is very important. So if the baby gets mother milk or formula has a big impact on the microbiome composition. Then there's also the age of the baby at birth. Even the birth weight can have an impact on how the baby will evolve with the bacteria. So there's a lot of things to consider, and it's driving me crazy, but it's overall very interesting, and maybe I found a time to give you a bit more interest in that. And if you want to have more information, just Google some of it, because there's a huge mass of information going around for the microbiome at the moment, because it's becoming a field of research that is quite big and intense. So it has been quite neglected for a lot of time, but now people are recognizing that the microbiome is really important for our health, for our immune system, and that's why it's becoming more and more important to have a look at it. So I hope maybe I got you interested. If you want to have more information or ask questions, just go right ahead. See you. Bye.